in this lesson we're going to be looking at slope. So we're still dealing with graphs, we're still looking at linear functions. Slope is going to be used to describe the steepness of a straight line. As far as how to find the slope, we want to be able, we're very aware of the ratio and how it's set up. A lot of times you'll hear it as rise over run. One thing you need to know is that the rise is considered that vertical change, which is your up and down, which is really that change in y that we looked at with rate of change. That value will go over what they call the run, which is the horizontal change, which is your change from left to right. And again, like rate of change, that was that change in the x value. Let's look at an example of how a slope can describe the steepness of a line. We have 2 points here, one point at 1, 2, so the x is 1, the y is 2, and then another point down here where x is -1, y is -3. These are going to fall on a straight line, but we're going to talk about the slope between those 2 points by looking at the rise over the run. So let's talk about how we can go from one point to the next. So we're going to talk about the vertical change first. That's always going to be that top number. So let's go from -1, -3 up to 1, 2. So we're going to be rising 1, 2, 3, 4, 5 units. So that's going up 5. So since we went up, that's going to be a +5. Then to get to that point, we have to make one more move, and in this case, we're going to go right 1, 2. Since we went to the right, that's going to be a positive as well. So in this particular situation, the rise was 5, the run was 2, so our slope is 5 over 2. Now you can also write that as 2.5, but we're going to be keeping them as those fractions or improper fractions so that we can be counting on the graph. So we can look at 5 over 2. Now you can also go from 1, 2 down to -1, -3. We'll be going down 5. So here we'll do this in a different color. When you go down 5, that's a -5. Then to get to that -1, -3, we have to go left 2, which when you go left, we're going towards those lower values, so that's going to be a -2. -5 over -2, negative divided by a negative is still going to be a positive. So there's 2 ways that you can move, you'll get the same slope. Now let's look at an example of how we can find slope from a table. You have your x's and you have your y's. So again, we're going to look at the rise over the run. Remember that the rise is that vertical or the change in y. The run is the horizontal or the change in x. So this is very similar to what we did with rate of change. We're going to look at these y's first. How do those y values change? We go from -2 to -1, so we're adding 1. -1 to 0 is a +1. 0 to 1 is a +1. So it looks like we've got a constant going, so that rise value looks like it's going to be that +1. Let's look and see if it's consistent for the x's. The x's, you're going from -6 to -2, so that's an increase of 4. -2 to a +2 is another increase of 4, and 2 to 6 is another increase of 4. So it looks like we're going up 1, right 4. So our changes in the x's, or the run, is a +4. So that means on the graph, these points, you'll be going up 1 and right 4. So that's a +1/4 slope for this situation. Now you could graph these ordered pairs and then count the boxes on the graph. You will be going up 1, right 4. Another way to find slope is to use the actual slope formula. When you use the slope formula, you're going to be using 2 ordered pairs on the line, and you want to think of those ordered pairs as x1 and y1 and x2 and y2. because you're going to be plugging them into specific points in the formula. M represents slope. That's the variable used to represent slope. You'll be familiar with that. The formula for slope is y2 minus y1. Again, the difference between the y's, or the change in y. Over x2 minus x1. So let's look at an example of finding slope using the formula. We're going to find the slope of a line that contains the 2 points 2, 6, and 4, negative 3. My suggestion is to go ahead and label these two ordered pairs with x1, y1 and x2, y2. That way you know exactly where those values are going to go into your formula. So I always just kind of write above it x1, y1, x2, y2. And that really just means this is the first ordered pair, this is the second ordered pair. Now we're going to plug these values into our formula. So we're finding slope, but we're doing it in a different way. We're not graphing it and counting the boxes. We're just putting it into a nice formula where we can do all the work on our paper. So we're going to put in negative 3 for y2. And then we're going to write our minus sign. y1 is a 6. So we're going to be doing, for our change in y's, negative 3 minus a 6. Make sure you're subtracting the y's. And then use the same order when you go to subtract your x's. So x2, which is 4, minus x1, which is 2. So we're going to go ahead and do the math. So we're going to look at the change in y's. Negative 3 minus 6 gives me a negative 9. And 4 minus 2 gives me 2. So our slope here is negative 9 over 2. So we have a negative slope. What that means is you're going 9 down and 2 to the right. Okay? And we'll look at more examples where you can look at this another way. But in the end, our final answer would be negative 9 over 2. Okay? You can also write that as negative 4.5. But like I said, we're going to keep these in fraction form for right now. So we're going to do more examples in class so that you understand slope.